Okay, this is the start of the 7th unit. I guess we've been doing these video lessons for a while. I wanted to just quickly chat with you about sort of what the expectations are. At some point I will send out an email to everyone letting them know how their marks are going to be derived. I don't want you to worry about that. I really, and I truly mean this, I really want your focus to be on learning the content. You're grade 11 students, you're going to be taking grade 12 math, whatever that's going to look like next year, whether it's in class or whether it's videoing like this. You need the content for grade 11 to do well in grade 12. So hopefully that's your focus. Don't worry about, if you submit your tests, what the mark's going to look like. I will let you know if the mark counts. For right now, we're doing this because I want to, kind of keep track of you, give you feedback on how you're doing. That should be your focus. Do the best you can, learn the best you can. If you're having trouble, send me an email, send me questions from your textbook, whatever. If you feel more comfortable, we can try the Microsoft chat. Send me a chat, and I think we can even video on there. If that I'm an old guy. I don't know some of these things, but we can definitely try to communicate with you to try to make sure that you're understanding. I will try to help you the best I can. Okay. I'd also encourage you to talk to your friends. Go search other videos. I'm not going to tell you that my videos are the best. They're teaching from the skeleton notes that you guys have. If you don't have printed copies, you can print them. They're posted on our My site. So do the best you can, but please let me know where you're struggling. Let me know if you have questions. I will answer this quickly as I can. Okay, so let's get into today's lesson. We are moving into a new unit. This unit has to do with rational expressions and equations. Very quickly, do you remember what a rational number is? Okay, a rational number, we talked about in the past, it has a definition. A rational number basically is any number you can write as a fraction. Okay, so think about what kind of numbers can be written as a fraction. Well, all of the numbers like 0, 1, 2, 3, all of these numbers can be written as fractions. Okay, any of the integers, so -3, -2, -1, etc., those can be written as fractions. Any number that is already a fraction obviously can be written as a fraction. And then decimals that terminate, if they, in other words, they end, these can be written as fractions, but also decimals that repeat. So, for example, 1, 2, 1, 2, 1, 2, that repeats, or decimal 3, 3, 3, the threes keep happening. These are repeating decimals. They can be written as fractions. The ones that can't are the ones that don't end and they don't repeat. There's nothing in them that, continues. Doesn't repeat over itself. So we've used examples as, like √2 or pi. These are examples of decimals that go on forever and don't have a repeating pattern to them. Okay? So what is a rational expression? Well, a rational expression is one where there is a fraction and there's going to be a variable in the denominator. Okay? And let's quickly take a look at what happens when there's a variable in the denominator. Here I give you 3 values for x. We're going to stick them into each of these. Okay, let's see what happens. Okay, so if we put x is 2 into this expression, you'd get 3. If you put x equals 2 into the next expression, you'd get 8/4. And then here we have a problem. If we put x equals 2 into this one, you actually get 2 minus 2, and if you have 3 divided by 0, you get something that we call undefined. Your calculator will say there's an error. All right? Got to keep note of that. Okay, if we put x is 2 in the next one, whoops. X is 2 in the next one, we're going to get 2/4 minus 12 plus 8, which is 0. Again, this is a problem. Okay, if we put 2 in this next one, we're going to get 3/4. That's okay. Okay, so what's the moral of the story here? Well, x equals 2. These two, we have a problem. Okay, looking at the next one, if we say x is 0, then here we get 6 divided by 0. This is going to be undefined. Okay, the next one you're going to get 0/2. Well, that's okay. That just equals 0. Here you're going to get 3 over negative 2. That's okay. Here you're going to get 0 over 8. That's okay. And here you're going to get 3 over negative 2. That's okay. All right. And then if we try x is 1, we would get 6 here. We would get 4/3 here. If we put x is 1 here, you'd get 3 over 1 minus 2, which is 3 over negative 1, which is negative 3. Okay, if we put 1 into the next one, you would get 1 over 9 minus 6, you get 1/3. And then if you put 1 here, you're going to get 3. Okay, and so this is going to be 3 times 0 times 3, which is undefined. Okay, so what are we noticing here? What's sort of the trend? When the numerator and denominator of a fraction are polynomials, the fraction is called a rational expression. Okay, in other words, like I said before, if there's an x in the denominator or some other variable. Rational expressions are not defined. They're undefined for values of the variable that make the denominator equal to 0. These values are called non-permissible values, or they're restrictions on the variable. Now, remember, we had restrictions on the variable in our rationals unit. The radicals unit. Okay, remember we couldn't have a negative number here, and so we were looking at restrictions there. If you remember, here was an example. So we would say here that x cannot be less than 0, right? Or we said x has to be greater than or equal to 0. Okay, those are restrictions. Okay, a rational expression is an algebraic expression that can be written as the quotient of two polynomials. Quotient meaning we're dividing. I've already said this. Okay, these are rational expressions. These two are not. Why not? Well, here, because there's an x in the variable, and here, because x can't have a fraction as an exponent. It has to be a whole number or an integer. Okay? So, let's get into some questions. Oh, by the way, in terms of these questions here, I think there was a multiple choice on the test last year, multiple choice question, where it just said which of these is not a polynomial, or not a rational expression. Okay, so you would just have to pick out the one that had either x in the exponent or x had a exponent that wasn't a rational number. Okay? So, determine the non-permissible values of each rational expression. Okay, whenever you get these, I'm going to tell you should always factor. Okay, so x minus 3, x plus 3. All right, and it's just saying what are the non-permissible values. So we're looking here and here. What would make the denominator 0? Well, we're saying, you don't have to write this out, but basically we're saying when would this be 0? Well, we've done this already. If x was a 3, this whole thing would be 0, or x would be negative 3. So this means, because of this, we say that x cannot be plus or minus 3, because that would make a 0 in the denominator. Okay, let's try this one. Again, we'll factor. Okay, I think this is x minus 4, x minus 4. And so what would make the denominator 0? Well, x cannot be 4, because if it was, you would get 0. Okay? Now, to simplify, you have to understand what is the equivalent form of a rational number. Now, you guys already know this with fractions, right? Fractions are equal, but we can still simplify them. Okay, so for example, 12 over 18, if I multiply by the equivalent of 1, this is still the same as this. Now it looks different, but they're still equal. Okay, I can also divide by the equivalent of 1. Okay, this is like 1. If I divide that, I get 4 over 6. In fact, I could divide by 2 and get 2 over 3. These are all equal. They're equivalent. They're the same number. Okay? This strategy can also be used with rational expressions. All right, so take a look at this. Here, what am I multiplying by? This is equal to 1. Here, what am I multiplying by? This is equal to 1. Okay, so in other words, these two expressions are equal. Okay, and we're going to use that principle to simplify rational expressions. Okay, these are all equal. Obviously, they don't look the same. They're equal or equivalent. The key here is that they all have the same non-permissible value. They all have x cannot be 0. You can't change this expression. So for example, if I said 20 over x, and here we have the original expression, if I now said, let's multiply that by y over y, okay, so this would give you 20xy squared over 8x squared y. This one is actually not equivalent. Why is it not equivalent? Well, they're really the same value, except that here we also have that y can't be 0. Originally, we just had x can't be 0. Okay, so we have to be careful when we're making equivalent expressions that we don't take away or add to the non-permissible values. So this one is not equivalent. So let's look at this. It says use multiplication and division to write two equivalent forms. Now, I'm not going to do this to you on a test. I'm not going to ask you to write equivalent forms. Usually I just ask you to simplify. Okay, and if you were simplifying this, you would say, let's reduce a common factor. So you would say, well, that's the same as x over 5, x plus 5 over 2. It's the same thing as if you said, 10 over 5. This is the same as 2 over 1. These are equal. Okay? The problem is these two aren't equal. Well, they are, except for one thing. This one has a non-permissible value of x can't be 1. So to make these two equal, if I want these two to be equal, I need to say here x can't be 1. Now these two are equal. Okay? So that's 1. It says we're supposed to come up with two equivalent. Here's 1. Let's come up with another one. Okay, so I want it to be equivalent to x plus 5 times x minus 1 over 2 times x minus 1. What could I do to this fraction or rational expression to make it equal? Okay, would it be okay for me to say, let's do this. Let's go x over x. Is that okay? It's not. Because originally we had x can't be 1. Now we would also have x can't be 0. Okay, so that's not okay. Would it be okay for me to say, let's multiply both by 5. This is equal to 1. Is that okay? Yes, that's okay because we don't have any new non-permissible values. So there is another equivalent fraction. Okay? Again, you can multiply or divide by a 1 as long as you don't have a new non-permissible value. All right. Let's get into the meat and potatoes of the lesson. This idea of simplify. This is going to be most of your tests. You're going to simplify rational expressions. If you think about the radicals unit, we added, subtracted, multiplied, and divide. We simplified. Okay, that's the same idea. We're going to simplify. Okay, so, and usually when I say simplify, I want you to reduce. Okay, it's like making a fraction in lowest common terms. So can I divide 25 and 35? Yeah, I can divide them both by 5. So you get negative 5 over 7. What about a? Can I divide a? Yeah, a cubed, take away a. This gives you a squared here. How about b squared over b to the 5th? Sure, that gives you b to the negative 3, and then c. How did I get b to the negative 3? Remember that if you have bases that are the same, we subtract the exponents. Okay, now, when it says simplest form, one of the rules of simplest forms is no negative exponents. Okay, so then we can't quite leave this. what do I have to do? Well, that b becomes positive if I move it down to the denominator, the reciprocal. Okay, so that's simplified, but I have to state the non-permissible values. Well, b cannot be 0, right? So if I put a 0 there, the denominator would be 0. And, put a little star here, always check non-permissible values in the original. Okay, here's what I mean by that. Originally, what did we have in the denominator? We had a and b. So we also have to say a can't be 0. Okay, this is a common error. Look in the original question. Okay, next one. Let's simplify. Before we simplify, let's factor. Is there a factor in the top? Yeah, I can take out a 6x, and what am I left with? X plus 2. Okay, can you simplify now? Yeah. 6x divided by 2x is 2, and I still have x plus 2. X cannot be 0. Okay. Next one. Factor it. X minus 7, x plus 7. And now, here's a little clue. I honestly think one of the factors in the denominator will be the same, so we can reduce. So I'm going to guess x, let's guess x minus 7, and that turns out to work. Okay, what can simplify? I can cancel that out. So simplified, I have x plus 7 over x plus 2. What can x not be? Look in the original. This is factored, this is before I've simplified. X cannot be 7, cannot be negative 2. Okay, and then the last one. A little bit of a trick here. Okay, normally the idea in the notes is that I show you everything that could happen so that there are no surprises on a test. Okay. Before I do any simplifying, let's just quickly say x cannot be plus or minus 3. Now, are there any common factors? There are none. Is x minus 3 the same as 3 minus x? Well, yes and no. They're not the same right now. Okay? You know, if we rearrange them to kind of look more the same, I have a negative x plus 3. You can see those aren't the same. Okay? But I can make them the same. All right? And this is a common little trick. If you see two binomials that the signs are reversed like that, they actually equal negative 1. Here's why. What I'm going to do is I'm going to factor out a negative 1 from the denominator. If I take out negative 1 from negative x, I'm left with x. If I take out a negative 1 from plus 3, I'm left with negative 3. And now if you look, you can cancel out the x minus 3's. And this whole thing is equal to negative 1. Okay, so simplifying this, I'm going to be left with 2x plus 1, 3 plus x, and I have this negative 1. So I'm going to put that there. And now just distributing that negative 1, I get negative 2x minus 1 over 3 plus x. Okay, so that's the simplified version. This thing here, this, you know, if I have 5 minus x and x plus 5, that equals negative 1. If I have x minus y over y minus x, that equals negative 1. If I have x minus 1 over 1 minus x, that equals negative 1. Always. Okay? Keep that in mind. All right, and give you a little bit of homework to try. I know there is a worksheet posted. Okay, you should try that. That's kind of directly the same kind of questions. And also on page 527, I have numbers 4 to 8, 10 to 12, 14, 15. Okay?